Assalamualaikum. We are from Group 6, Mathematics Section 2. Today, we would like to present about our project assignment. Hello everyone, my name is Muhammad Indra Arman bin Muhammad Sirun, no matrix CB240271.
Hi, my name is Jared Xavier Anak Sidot and my metric number is CB240173.
Assalamualaikum and hi, my name is Muhammad Zakwan bin Azizan, metric number AB240002.
And my name is Nadia Natasha binti Adnan. My matrix number is AB240004.
Before we start our presentation, I would like to read about the question that has been given. You are a marine biologist studying the population dynamic of a particular fish species. You are interested in understanding the contribution of three primary factors to overall the population. The first one is temperature. Each degree Celsius increase contribute 100 units of growth. Next, we go to the availability of prey. Each increase in prey availability contribute 150 units growth. And then for the last one is predator population. Each increase in predator population contribute negative 80 units of growth. Okay, let's go. You want the fish population to reach the specific growth target. That is 500 units of growth from temperature, 800 unit growth of prey availability, and 400 units of growth from controlling predator population. Okay, let's go to the problem, that is to determine the increase needed in each factor, that is temperature, prey availability, and predator population to achieve the desired growth target for fish population. Okay, let's go for the introduction. Linear equation is a mathematical statement that shows relationship between variable and constant. Where the variable are raised to the power of 1, it's called a linear because its graph forms a straight line when plotted on coordinate plane. Linear equations are fundamental in algebra and are widely used in real-world applications, such as calculation cost, determining distance, and modeling relationship between two variables. Okay, for this question, our group decide to use linear equation to find the answer.
Next, we go to the problem statement. As a marine biologist studying the population dynamic of a specific fish species, we aim to understand first, the contribution of three key environment all factor to the overall population growth. Second, this factor include temperature, prey availability, and predator population. 3. Each 1 Celsius increase in temperature contribute 100 to the growth of the fish population, while each increase in prey availability at 150 unit of growth. On the other hand, each increase in predator population has a negative impact, reducing the growth by 18 units. 4. The goal is to achieve specific growth target for the fish population, where 500 units from temperature adjustment, 800 units from increased prey availability, and 400 units through controlling the predator population. 5. The task is to determine the necessary increase in each factor temperature, prey availability, and predator population to reach these desired growth targets.
Next, I will proceed our presentation about the objective. Okay, so our objective we have put it into three sections, which is the first section is to determine the optimal adjustment needed in environmental factors, temperature, prey availability, and predator population, and to achieve specific fish population growth targets. And secondly, to calculate the precise changes required for each factor 500 units from temperature management, and 800 units from prey availability, and 400 units from predator population control. And the third objective is to analyze the relationship between the environmental factors and the contribution to overall fish population growth using linear algebra techniques.
The topic that we use in this question is linear equation. But before we start answer the question, I want to show you the example of the questions. So here we have negative 2 equal to negative k plus 3. We want to find the letter of k. So how can we find the letter of k? Is the negative, we need to bring the negative k in front to make it the subject. So negative 2 plus k. Why I write the plus sign here? Because at here we have the negative sign, but when we bring it in front, the negative sign will change to the positive sign. So negative 2 plus k equal to 3. And then we just want the letter k. So we need to bring the negative 2 behind. So when the negative 2 go to the behind, the sign of the negative will change to the positive. So k equal to 3 plus 2. And then we can solve the question. So k equal to 5. So this is the answer. If you want to check whether the answer is correct, so you can just check like this. So negative 2 equal to negative, we can insert the 5 in the k because k equal to 5, negative 5 plus 3. So when we count the questions, it will be same. Negative 2 equal to negative 4. So the answer is correct. And then now we come back to the question. Now let's back to the questions. The questions here is they want to search for the increase needed in each factor, which is temperature, availability of prey, and predator population. So I have the formula here. The formula is growth equal to factor multiplied with coefficient. The growth will mean the target. So the target here, for temperature we have 500, and then for the prey availability we have 800, and then for the predator populations we have 400. And then for the factor here, it means what we want to search. Where we want to search the increase for the temperature, stand for T, and then P is stand for the availability of prey, and then D is stand for the predator populations. And then the last one, we have coefficients. The coefficients here means each increase by how much. So at here we have temperature, we have 1 degree Celsius increase by 100. And then for the availability of prey, we have 1 equal to 150 of growth. And then the last one, we have 1 equal to negative 80 of growth. So that's mean for the formula that I made. And then now what I want to do is I want to search for the increase for the first factor, which is temperature. So the first factor is temperature. So now I have the factor, coefficient, and the growth. The factor for the temperature is T, and then the coefficients of the temperature is 100, and then the growth of the temperature is 500. So we just can insert in the formula, which is growth where 500 equal to the factor multiplied with the coefficients. which is 100. So we can use the linear equation to solve this question. So we need to make the t for the subject. So t equal to 500 over 100. Why it can be like this? Because I bring the 500 to the behind, and then I bring the t to the in front. So when I bring each other for another side, it will be the divide sign, because at here we have the multiply sign. So at here we have the answer is t equal to 5, which is the temperature is increased by 5. And then same goes to here, availability of brain. The factor is P, the coefficient is 150, and the growth is 800. So growth 800 equal to the factor multiply with the 150. So P equal to 800 over 150. So the answer is 5.33. So it means the availability of prey is increased by 5.33. And the last one, we have the predator population, which is the factor is D, the coefficient is negative 80, and the growth is 400. The growth is 400 because at here the target that we want is 400. Okay, so we can just insert it in the formula, which is the growth 400 equal to the factor multiply with the coefficient. So it will be like this, D equal to 400 over negative 80, and the answer is negative 5. At here, the negative sign means decrease. So it means the predator population is decreased by 5. So that's all. So this is the answer for these questions.
So, thank you, Nadia, for the explanation for the linear equation just now. Okay, so we will go through into the conclusion. Okay, so the conclusion of this linear equation is the study identified the best adjustment to 3 environmental factors to boost fish population growth using linear equation, and it's calculated the following changes. So increasing temperature by 5 degrees Celsius would lead to 500 units of growth, and raising prey availability by 5.33 units will result in 800 units of growth. And third, reducing predators numbers by 5 would achieve 400 units of growth. And the finding shows that the prey availability has the biggest positive impact, followed by the temperature, while predator control requires a careful balance. And this approach highlights how mathematical tools like linear algebra and can solve ecological problems and guide sustainable fishery management. Thank you. Okay, so with that, that's all from our group 6, and thank you for having your time to see our presentation and our assignment. And thank you also to Sir Fitri as our lecturer for this semester. Thank you for everything. Okay, that's all. Bye bye.